Good afternoon and welcome to today's IOUG and ODTUG co-hosted CodeTalk webinar. My name is Alexis Polak and I'm the Education Manager for the Independent Oracle Users Group. I'm pleased to be your host for today's session, which is Oracle Database Development at Moovit. Before we begin the broadcast, I would like to remind our attendees of a few housekeeping items. Please note that all attendees are in listen-only mode for the duration of the broadcast, and this means your microphones are turned off. If you do need to ask a question or have a technical issue, please enter your question in the GoToWebinar toolbar located on the right-hand side of your screen, and a staff member will be happy to assist you with that request. Additionally, during today's broadcast, our presenters will be using their webcams, and so you will see slides advancing as well as 2 or 1 video cameras on screen at all times. This may mean that slides do not advance on a regular basis, but please note that the presentation is meant to be a conversation, and so if the slides are not changing, you should direct your attention to the video cameras. At the end of today's session, there will be a brief survey asking for your feedback and how we can continue to improve the CodeTalk series, and we will be doing a Q&A with our presenters at the end. Please feel free to enter your questions throughout the duration of the presentation, and we'll share those with the presenters at the end of today's session. With that, I'd like to introduce our presenters for today. With us, we have Stephen Feuerstein from Oracle. Stephen is one of the foremost experts, if not the foremost expert, on Oracle PLSQL. He's authored multiple books and speaks at conferences across the world on this topic, most recently at Oracle Open World, which is actually incidentally where he met Oren. And then with us today as well is Oren Nakdimon. Oren is the database expert at Moovit in Israel and is going to share his story with us today about how Moovit is using PLSQL to advance their state in the industry. I'm going to turn things over to Stephen at this point to kick off the conversation.
Thank you, Alexis. Hopefully you can all hear me clearly. So yes, my name is Stephen Feuerstein. I'm the Oracle Database Developer Advocate for PLSQL. I have been working on PLSQL exclusively pretty much since about 1991. And so you might have seen my books, my videos, etc., and hopefully you've learned a lot from me. But the CodeTalk series is about something a bit different than that. What I hope to do with this series is feature the voices and experience of Oracle database developers from around the world who you may not know about, but are doing absolutely amazing stuff in the real world. I sort of live in the real world, but maybe not as much as I should. In any case, I'm really excited to have with me today Oren Nakdimon, who is a database architect and lead developer at Moovit, which is a transit app, and he's going to explain in more detail all that stuff. The reason I asked Oren on this show is that I went to a talk he gave on EBR, edition-based redefinition, at Open World this past September, and was really impressed with what they've done with EBR, which allows for hot patching and zero downtime and all that really cool stuff. But he had this one slide about his favorite PLSQL features, and for me, of course, anybody who wants to talk about favorite PLSQL features, my kind of guy or gal. So I thought it would be great to follow up on his EBR presentation to hear in more depth about how they use Oracle Database generally and how and what they like about PLSQL within that context. So Oren, welcome to the show. Let's hear more about yourself and let's dive into the conversation about using PLSQL and Oracle Database to build apps.
Hi, Stephen. Thank you for inviting me. Okay, so I'll introduce myself shortly. I have been working with Oracle-based systems for quite a long time now. I started more than 20 years ago with Oracle 6, SQL Forms 3.0, and PLSQL 1.0. I have done various roles throughout the years, but I see myself foremost a database-oriented developer, and the work that I do is mostly database-oriented. This is why I chose the name DB-oriented when I started the freelance activity a few years ago, and I used the nickname DB-oriented for my activity in the Oracle users community. I'm a board member of the Israeli Oracle user group, and I have been working for Moovit since it started more than 4 years ago, and I'm responsible for the database development and administration. I tweet using the handle DB-oriented about Oracle stuff that I find interesting, and I write in my personal blog, dboriented.com, once again about Oracle stuff. I'll tell you a little bit about Moovit. Moovit is a 4-year-old company. We have about 95 employees. We are based in Israel and San Francisco, and we have investors from very top-tier VCs around the world. These numbers clearly set the stage for our product. About 8 billion people around the world and only 900 million cars. What it actually means is that most people don't use private cars, so they use public transit and other means of transportation. Based on our user statistics, public transit is a big part of the life of most people. It takes between 1 hour to 2 hours every day of people's life. And Moovit provides a very unique solution that incorporates multiple sources of information. Data that comes from official sources like schedules, service alerts, points of interest, public transit agencies data like GPS location of buses and trains, updates and alerts, and we collect data from our users, so it's a crowdsourced based app. And as a result, we take this information into one repository and provide our users with multimodal trip planning, real-time data, alerts, and mobility options. Moovit is not only about public transit. We incorporate today options to combine public transit with taxi or even carpool service that we started to operate. We are the leading public transit app around the world with more than 45 million registered users. We provide our service in 45 languages in 67 countries and today more than 1,200 cities around the world. Our database includes millions of bus and train stops. We provide data of thousands of transit operators around the world. Stephen, you're in Chicago, right? So Chicago CTA, for example, is just one of those operators.
Excellent.
And we collect more than 100 million data points a day from our users. This is something we are very proud of. We release a service in a new city every 18 hours on average. So every 18 hours, there is a new city added into the Moovit repository. And we can do that because we have more than 75,000 editors that volunteer to help us in 140 countries. And they are working on about 2,000 new projects, which represent 2,000 more cities to come.
Busy, busy, busy. That's pretty impressive. And yes, I do take transit every once in a while in Chicago. Mostly I just stay in my basement and work. But when I do, I'm going to be checking out Moovit. So big, complex app, lots of users. Tell us how you're able to use Oracle database to support that kind of activity.
Okay. We use Oracle as our main database. We use 11.2 standard edition, hosted in Amazon RDS, and currently contains about 4 terabytes of data. We have different types of application servers connecting to the database. Each type is responsible for one or more functional areas of the system. Each server uses a connection tool and opens multiple connections to the database. We have several servers of each type and are clustered behind load balancers. And there are several types of clients served by these servers. First of all, our mobile end users. We have a web version of the trip planner, a community editor used by our community to add and update data, and we have some internal tools used by our operations team to configure, control, and monitor the system. In addition, we load data into Oracle from various sources, and we have some other non-Oracle databases that we use for specific purposes, and they are populated with data from the main Oracle database. We like taking advantage of the capabilities that the database offers. For example, we use external tables for loading data from external sources into the database. We use Oracle Locator for performing geographic calculations. We schedule jobs in the database. We send emails from the database. We care about data integrity. We use constraints for every business rule that can be expressed in the database, and we use triggers from time to time, again for validating the data, not for performing some hidden logic. So we use the database not only for storing the data, but also as the last tier of protection of the data correctness and integrity as much as possible. We use PLISQL, and I'll give you a few numbers. We have about 650 tables, 120 packages, and about 100,000 code lines in the database. So I guess it means that we really use PLISQL.
And you use packages, which is very nice, because I still occasionally run into people who say, our DBA told us not to use packages. They use too much memory and so on and so forth. And to me, the message should be clear. You start with packages as your basic building block.
Of course. And that, I think that I'll elaborate on the advantages of packages, of course.
Mm-hmm.
Okay, so I'd like to tell about how we develop, what is the process of the development or the things that I think make us successful in our development process. And a key factor in our successful development process, as I see it, is the relationships between the application servers and the database server. There is a very clear definition of how the app servers can access the database, what they can do and what they cannot. And the major rule is that the app servers make only PLSQL calls to the database server. All the communication with the database is done by calling PLSQL procedures and functions that are stored in the database in packages. In other words, all the SQL statements in our system are written only within PLSQL program units. There are no SQL statements outside of the database, which means that the app servers cannot access tables or views directly. And this gives us many benefits. First of all, SQL statements are written only by Oracle developers. In many software development organizations, SQL is treated as something that every programmer can do by the way. You are a Java developer, for example, then you write Java as your main job, and whenever you need to access the database, you write SQL. So they have dedicated Java developers or dedicated C++ developers, etc., but no dedicated SQL developers or database developers. And then in these places, there are sometimes problems with the database. Performance problems, security problems, scalability, concurrency, data integrity issues, etc. SQL is a programming language. It is rich, it is powerful, and like with any programming language, you can write good code with it and you can write very bad code. And as with any programming language, in order to write good code with SQL, you need to be a professional SQL developer, or more accurately, in our case, a professional Oracle developer. You don't let a programmer that doesn't know Java, for example, write your Java programs, right? At least not your important Java code. I think it shouldn't be different with SQL. I even think it is more important with SQL because SQL is fundamentally different than all the popular programming languages used for application development. Because SQL is set-based. You need to think in sets, and this is a skill that you need to acquire. If you are used to write in a procedural way, you might write an inefficient SQL, processing one row at a time instead of a single statement that processes a set of rows in a single operation. And SQL is very rich and powerful. If writing SQL is not your profession, then good chances are that you don't know many of its features. If you know only the basic syntax, select, from, where, perhaps group by, and you don't know about analytic functions, for example, or inline views, or subgraph factoring, or how nulls behave exactly, then the SQL statements that you can write are limited. You may write inefficient, cumbersome, more error-prone, harder to maintain statements. And in this context, I really like what Tim Hall once wrote in his wonderful website, oraclebase.com. You wouldn't ask an inexperienced person to fix your car, so why would you ask one to write SQL for you? Next benefit is that the API and the implementation are separated. The PLSQL package specs are the interface for the app servers to access the database. The implementation is encapsulated in the package bodies with all the benefits that encapsulation gives in any normal programming language. Here we actually have two different levels of flexibility. We can change the implementation of a procedure without affecting the app server code. We can, for example, optimize a SQL query or change the business logic or fix a bug. And the app server code should not be touched as long as the API is not changed. But the second level of flexibility is even stronger. We can change our data model without affecting the app server code. I think this is really powerful. And this separation also makes the development process more efficient and more effective. we first define the API, which means we must think and plan and design before starting the implementation, which is a good thing, of course. And then once the API is in place, we can work in parallel. The database team on our implementation and the server team on theirs. And many times we even provide them stubs, an empty implementation, so they can even compile their code and call the stored procedure before the real implementation is done. And here is a real example from last week. We agreed about the API with the server guys and declared this procedure in the package spec. Then immediately we wrote this initial implementation in the package body. It doesn't do anything, but the app server team can start their implementation. So this is how the implementation was 1 week ago, and today it's already fully implemented. The third benefit is higher reusability. We have several types of app servers and relatively many app server developers. And from the other side, we have one central database. And all the app servers use it, and there are tables that are used by several app server types. Think, for example, of users' data, or metropolitan areas, or bus stops. These are naturally very central tables in Moovit database, and are used by a lot by all the servers. If the SQL statements were written in the app server, we would probably see the same or similar queries duplicated in different places. But since we write the SQL in PLSQL, we can better reuse the code. We can write one query in one procedure and let different servers use it, maybe with some parameters to support similar yet different requirements. Automatic dependency tracking, this is a really cool feature of Oracle. Oracle automatically keeps track of the dependency between the objects in our schema. So since we write SQL only in PLSQL, we can analyze very easily the implications of a table change, for example. It would have been much harder if SQL was written outside of the database. Here is a small script I use a lot, showing for an object its dependence hierarchy and the hierarchy of objects that depend on it. So this is the script, and here we can see an example of using it. Another cool thing about storing your code in the database is that it is stored in tables, just like any other data. So we can use the select statement to search our PLSQL code. There is another small and very simple script that I use a lot, simply selecting from user source dictionary view to find some string. Or this one, to quickly get a window of source code from a package body. I called some function and it failed. I see from the stack that it failed in strutil in line 316. So I can quickly see this line within a window of 5 lines before it and 5 lines after it. It's not instead of my IDE, of course. It's just a quick helper. Now, this restriction of not writing SQL in the app server and making only PLSQL calls.
Go back to one question from the previous talk, though it might be what you're about to say. So in terms of the overall architecture, that first statement, no SQL in the app server, in the app code, all inside PLSQL APIs, was that something that was a difficult place to get to in your organization, or was that really this, everybody agreed from the start about it? Because a lot of developers I talk to have this ongoing battle around this very topic, or a variation of it.
Yeah, so I had the luxury of starting from scratch with a very small and wise team in the server side as well as in the database side. So we didn't have any problem with it, but I think that I will count now the benefits that the server side has in addition to the database. I like to think about this rule, this hard rule, as not as a wall, but as a fence, as in good fences make good neighbors. So I'll explain why.
Thanks.
So this was one aspect. Okay, of the relationship. The other aspect is that we must provide the app servers everything it needs from the database. And we do it via well-defined protocol and stable APIs. For example, as I said, we do all our database side development in PLSQL packages. The API for the app server includes all the procedures that are exposed in the package specs. Input parameters. When the app server calls a procedure, it always passes the parameters by name and not by position. This is very convenient if you have optional parameters that are not necessarily positioned as the last parameters, so you pass only the parameters that you need. But it has additional benefits. If later on we add another optional parameter to the procedure, we can locate it at the most appropriate position, not necessarily as the last parameter, and we're still maintaining backward compatibility and don't break the existing app server code. Obviously, if we add a new parameter, it is probably because the app server needs it, but it gives the server developers the flexibility to change the call at a later stage, or perhaps the new parameter will be used only by a new server code. And another benefit of passing the parameters only by name is that I can change the order of parameters as part of refactoring my code without affecting the server code. Output parameters. Naturally, we have lots of procedures that return data to the app server. In most of them, we use a ref cursor out parameter for that. And similarly to the parameters passing, the server gets the elements from the ref cursor by name and not by position. And once again, this makes the API stable. We will not break the server code if we add new elements to the ref cursor select list, no matter in what position. And it gives us the freedom to change the order of the select list items if we want to do it as part of code refactoring. User-defined types. Wherever we want to pass multiple entities as an input to a procedure, we use user-defined collection types. The reason for passing multiple entities can be either functional or due to performance considerations. An example for a functional reason can be a procedure that inserts into the database a parent entity with several child entities. An example for a performance-driven scenario is inserting a large number of records into a table. If the procedure gets only one record as an input, we will have many calls from the app server to the database, and this can be very inefficient in two levels: lots of round trips between the server and the database, and lots of small insert statements done by the procedure calls. Passing a collection parameter of, say, hundreds or thousands of elements to the procedure is much more efficient. And UDTs are helpful not only for collections. We have, for example, this composite type that we use in various places. It represents when something, like a public transit trip, is active. For example, of a specific bus trip that is active on every business day, Monday to Friday, from June 1st until December 31st, but not on the election day. This is quite a generic structure, and since we need it in various places, we define the type for it once, and we can use it as a parameter in multiple procedures. Otherwise, we had to specify many parameters over and over again, so it allows for reusability both in the server side and in the DB side. Another part of the protocol we define between the app server and the DB server is about exceptions. Each procedure may throw exceptions when something is wrong. For each expected exception, we define a unique error number and let the server developers know about it. So when we raise the exception using raise application error, the server code knows exactly why the procedure call failed, and it can take the most appropriate actions rather than just propagating a generic operation as failed error to whoever called the server code. And to make it clear and manageable, we define these exception numbers in ranges based on functional areas. We use the user-defined range of numbers that Oracle allocates to developers from -20,000 to -21,000 and divide it into sub-ranges, a sub-range per subsystem. And backward compatibility. Whenever we make a change in our PLSQL code, we try to minimize changes in the server code. Obviously, many times the server code must be changed. Moreover, many times we change the PLSQL code because of a requirement from the server. But when it is not necessary to change the server code, we usually maintain backward compatibility, making the DB side change transparent to the server. And it's quite easy to do in PLSQL. For example, the most simple use case is when we change the implementation of a procedure but not the API. This is backward compatible by definition. I've already mentioned that the server passes parameters and gets ref cursor elements by name and not by position. So if we add optional parameters or new items to an existing ref cursor, no matter in what position, backward compatibility is kept. And if we add a new out parameter to a procedure, but there are places in the server code where the procedure is called and they don't need the new out parameter. They are happy with the old API. We keep both APIs using overloading. For example, we had this procedure, handle failed file, that sometimes creates a new record as part of its implementation. And then we had a requirement to return the ID of this new record. So we added the new out parameter, but there are existing places that already use the old API and do not need the new out parameter. So we maintain backward compatibility by adding an overload of the same procedure without the new parameter. And note that the implementation of this procedure simply calls the other procedure. We will not duplicate the code.
That, by the way, is one of my favorite tips around overloading, making sure that there's always a single point of definition that all the other ones build on top of when it's appropriate. So it's nice to see that. And now it looks like you're going to talk about layers of packages, which I'm very excited about because I try to do that myself. I've promoted it in the past a bit, and it's something that takes a fair amount of discipline. First of all, getting the layers right, and then making sure you don't violate the rules between the layers. So tell us about your layers, Oren.
Yeah, and I can say that it was not designed like that from the very beginning. This was an evolution. We had a single package at the beginning, I guess, and then we had more and more. And we don't afraid of doing refactoring. So this is one example of an ongoing refactoring. And I think that now we have a pretty good model for this layers model. So we have, in general, 4 layers of packages, and they are based on the usage level. Procedures from a package in one layer may call procedures from packages in the same layer or in the layers underneath it, but not in higher layers. The lowest layer contains generic utilities that are not specific to our data model. They are like an extension of the PLSQL language, contain mainly pure PLSQL in their implementation and do not access tables. The kind of procedures and functions you may see in many places that develop PLSQL code. The second layer contains our core infrastructure, procedures that are not aware of our functional subsystems, but do handle the common components, the components that the functional subsystems use. For example, logging, purging, a generic process workflow that we developed and use throughout the system, etc. The third layer contains our functional subsystems. Naturally, most of our packages belong to this layer. Each functional subsystem has one or more packages. And the highest layer contains packages that are used only by our internal tools. They are also divided based on the functional areas. And the separation between the third and the fourth layers gives us more flexibility in terms of when and how we can make changes in them. And I think that it also helps you focusing when you know who is your end user and how frequently the procedure you are writing will be called, etc.
All right, my favorite part, your favorite PLSQL features. So what do you think has really made a difference in the day-to-day work for the application, and also just as a developer, the kind of things you really like and get a lot of benefit from?
So there are many features that I love in PLSQL, and I divide my most favorite ones into 4 categories. First of all, the features that allow for tight integration with the database. These features are what makes PLSQL, in my opinion, the best language for development with Oracle database. In this category, I'll start with anchoring. Whenever we declare a variable or a parameter that corresponds to a table column, we use %type. It's so beautiful. If we change the data type of the column later, we don't need to do anything. Oracle will recompile all the dependent objects automatically. But more than that, everyone that reads the code knows immediately the context of each variable and parameter. The code becomes more self-explanatory. Embedding static SQL in PLSQL code is very easy and clean, much more than any other language that I know. We basically just write our SQL statement. If it's insert, update, delete, or merge, we just write the statement. We can use variables in the statement and they will automatically become bind variables. If it's a select statement, we only add into and the variable names. Bulk processing.
Warren, one quick question before you proceed further. So I love PLSQL, but I'm pretty much stuck with it. It's almost all I know. Some SQL I did Fortran years ago. What other languages are you familiar with? So when you say these are the things I really love about PLSQL compared to other things you worked in, perhaps that might be also interesting to hear. Yes, I don't mean specifically, I mean just in general, what are your other languages that you have coded in?
Okay, so now it is pretty much only PLSQL in the last years, but I have programmed with many languages, and even in the days of Pro-C that I used a long time ago, still PLSQL is much simpler, because in any language you have all this extra stuff that you need to tailor the statement. It's not just writing the statement. You need to bind everything. You need to call separately to the parse the statement, and then execute, and then fetch it into variables in PLSQL. It's very easy, and it makes sense because PLSQL is the extension of SQL. This is its purpose. Okay, so bulk processing, which is very important for performance when working with SQL, is straightforward as well. We add two words, bulk collect to the select into, and that's it. We populate a collection. We add for all, and that's it. We made one DML statement be performed in a single execution bound to many variable values. And my top favorite feature in this category, and generally in PLSQL, is the cursor for loop. It is so elegant. We wrap our select statement in a for loop, and so many things are done automatically. A record variable is implicitly defined. A cursor is opened. The cursor is fetched into the record variable in each iteration. The cursor is closed when we leave the loop. And behind the scenes, there is even a prefetching. There is no context switch to the SQL engine in every iteration of the loop, but only every 100 iterations, at least since Oracle 10G. We can't hear you.
I was miming. What can I say? Yeah, so the point you just made about automatic optimization is also a point I like to drive home, because what you're doing with the cursor for loop is you're not writing a program. You're making a declarative statement to the engine saying, I want every row for this query. Get it for me. Do all the work for me. And so we like it as a shortcut, but what the optimization that started in 10G really reflected is that it's giving the compiler the freedom to figure out how best to implement your request for you, which makes it a declarative feature of PLSQL, whereas SQL is mostly seen as declarative, PLSQL procedural. There's a lot of declarative stuff in PLSQL too.
Mm-hmm.
Continue.
Okay, the second category of features that I like are ones that give it the qualities of a mature and powerful language. I'm not excited about the trivial if, then, else structures, case, loops, etc. I'm talking about overloading. The fact that you can have two procedures in the same package that do basically the same functionality but may get different types of parameters or different number of parameters. and we can give them the same name. The most appropriate name is something that I really like in my programming. We can get along without it, of course, but having it makes a difference to me. User-defined types, another powerful ability. We can create our own structures, we can create our own collection types, we can use them to define parameters and pass them to and from procedures. We can select into them, and a very cool ability, we can treat collection variables as tables and select from them using the table operator. Since we are still in 11G, we define most of our UDTs at the schema level and not in the package level, because in 11G you cannot apply the table operator on package level variables, but in 12C you can, and I think this is one of the best new features for developers in 12C. We use UDTs a lot. We have generic types that are used everywhere, like number TP, a table type of numbers, or number LTP, a table type of number LT, which is in turn an object type containing a pair of numbers. We have more specific types, but are still useful in various places, like service T that I showed earlier. And we have very specific types, ad hoc types used for concrete cases, usually for passing a batch of entities in a single parameter to a procedure. And there is additional compilation, which we use, not a lot, but this is one of these features that when you suddenly have some rare requirement, you take them out of your arsenal and they fit like a glove. We use conditional compilation, for example, for changing behaviors slightly between production and QA environments. I have been talking about my favorite features for a few minutes now, and I guess that everybody that knows me is surprised because I haven't said EBR yet. And EBR, addition-based redefinition, is certainly in a distinguished place in my favorite feature list. EBR is really cool and useful. It enables us to do any change to active production systems, from small bug fix to a major version upgrade, in an online fashion using hot rollover. We expose a new version, a new edition, while users are still using the old version, and different users may use 2 or even more versions at the same time. We perform the upgrade in the privacy of a new unexposed edition, which is a huge benefit in my opinion, without the regular pressure of completing the upgrade as soon as possible to reduce downtime, or the stress of not making any harm by mistake to a live system. We can do the upgrade at any time, not necessarily at off-peak hours. And EBR is supported in all the editions, including standard edition, and requires no special license. We have been using EBR for more than 3 years now. We upgrade the application once every 3 days on average, and sometimes even twice a day, during peak hours, and the users continue working without any interruption. In the last category, I want to honor some features that are considered taboo by many people, features that are considered wrong or bad practices just because it's easy to do wrong stuff with them. But they can be powerful and not risky when used wisely and appropriately. One of them is global variables. If they are used out of laziness instead of passing formal parameters, this is most probably wrong. But we use global variables for implementing session level cache, for example. Or triggers. I'm not a fan of performing some hidden logic in triggers, like changing the value of a column just before the record is inserted or updated. If all the SQL statements are done in PLISQL packages, then the procedures that contain the original SQL are the best place to locate this extra logic, and then it is not hidden anymore. But triggers can be helpful for implementing complex data integrity checks that cannot be done by constraints, like cross-row or multi-table constraints. And I'm certainly in favor of using the database itself as the final safety net for data integrity. I think it's a good opportunity to mention SQL Assertions, which would be the proper way to declare cross-row and multi-table constraints, and the better way than using triggers. But SQL Assertions are not supported by Oracle yet, and there is a proposal for that, raised and promoted by Tom Copeland, and whoever thinks it's a good idea support it by voting up in this page on OTN. So I said global variables and I said triggers, and now I want to show a small example for a use that I do with both a global variable and the trigger. Suppose that every time we add a record into T1, we have to do some additional stuff. So we write a procedure, insert T1, that inserts a record into T1 and performs this additional stuff. But what will happen if someone, perhaps even myself in 1 year from now, will insert records into T1 from another place and will not know or maybe forget about the mandatory additional stuff? The best thing would be to make this procedure the one and only way to insert records into T1. But how to do it? I'm adding a Boolean global variable and initialize it to false. And I change it to true at the beginning of the procedure and make sure to set it back to false when leaving the procedure. Now I'm adding a function, a public function, to get the current value of the global variable. And as the final step, I'm creating a statement level trigger. Before insert on T1, a trigger that doesn't change anything. It just checks that the global variable is currently set to true. So if I try to insert records into T1 not via the procedure, the trigger will not allow it. It will raise an exception saying inserts into T1 are allowed only via my package.insert T1. And finally, dynamic SQL. I praised earlier how smoothly we can embed static SQL in PLSQL. So whenever we can use static SQL, there is really no reason to use dynamic SQL. And indeed, almost all the SQL statements in our code are static. But we do use also dynamic SQL in some special cases. For example, we load many different files from various sources into the database. And we use external tables for that. Now, different files may contain the same kind of content, but each file may have a different structure. The order of the fields may differ, some files may have some extra fields, etc. So we wrote a utility that generates and executes DDL statements using dynamic SQL in PLSQL for creating these external tables based on a flexible configuration. Enough favorite features for you?
That is a really nice set of favorite features, and I think I enjoy all of those greatly myself, though I must confess that in my current application, the quiz platform, we haven't yet used conditional compilation, so it's nice to see that show up for sure. All right, well, we're almost out of time. I bet you've got some smaller features that you really like as well as these big picture features.
Yeah, right. I think that in order to build a successful application, and especially in an agile way, and we are very agile, it is important to pay attention not only to the big stuff that we've talked about a lot, but also to the small things. Small things that, in my opinion, make a big difference, like naming convention and coding standards. When you read code that someone else in the team wrote, or even old code of your own, conventions and standards save you lots of time and help you understand the code better. I know immediately that this is a parameter because it starts with P underscore, or a local variable because it starts with V underscore. These are examples of our convention, but it doesn't really matter how the convention is defined exactly. What matters is that there is a convention and that everybody in the team uses the same convention.
Consistency. It's not. It doesn't make any sense to have one if you don't follow it. You've got to be consistent. I agree.
Right. And beyond conventions, we try to make our code self-documenting. And it's easy with a language such as PLSQL because one of the fundamental principles of PLSQL is modularity. So you build your code from modules and you name each module, and a good name describes well what this module does. And if you have a big procedure that does lots of stuff, you can break it into sub-modules, smaller procedures in the most appropriate scope, may it be local or global. And each sub-module has a name that describes what it does. So you don't really need comments if you give good names. And it's true for everything we name, not only procedures and functions. we give names to variables and parameters and types and, of course, tables and views, etc. So they should be good descriptive names. I must admit that sometimes I spend more time on choosing the right name for some small procedure than on coding it, especially with the 30-character limitation that we still have in 11.2.
Time to upgrade to 12.2. Tomorrow,
Yes.
come on.
Tomorrow.
An Exadata Express in the cloud.
Right. It will take a few days more, I think.
Okay.
And I love labels because they allow us to give names even to internal blocks and to case statements and to loops, which is really cool, especially when we have nested loops and we use exit or continue. With labels, it is very clear from which of the loops we exit. I just wish the compiler enforced the closing label to be identical to the opening label. It doesn't, and that may cause confusions.
Maybe we could at least add a warning, so we flag them for you, even if we don't insist on it.
Right. Using constants instead of literals also make the code more clear. And something that is true in every environment, testing using a representing data as close to the production data as possible. Our QA database is a replica of our production database. We create a new QA database once in a while from a snapshot of the production database. And instrumentation, I think this is one of the best investments a developer can make. When something doesn't work properly, and I have instrumented the relevant piece of code in advance, then the investigation of the problem becomes so much easier.
A little bit on that. So how do you, not the details of the implementation, but do you have it set up so that you can turn on tracing in the app while it is live? You don't have to recompile your code or anything like that, and then where does the trace information go?
Yeah, that's right. And in a similar context, one last tip, whenever you call raise application error, pass through to the third parameter. It is an optional parameter, defaults to false, which makes it throwing away the full error stack.
Mm-hmm.
So when we pass through, the full stack is kept, which makes it much easier to track the root cause of the exception when it happens.
All right.
And
anything else?
That's it.
That was great. And we have a lot of interesting questions. So what I'm going to do is thank you, Aaron, for sharing your experience and utilization of PLSQL and Oracle database. Let's dive right into the questions so we don't go past the hour if we can and respect everybody's time. So first question regarding frameworks. So good frameworks like Apex, Oracle Application Express, already handle a lot of the DML complexity for you. So why use your own APIs? And isn't choosing the right framework just as important? I guess what they're saying is, why didn't you use Apex? But you don't really have to answer that question.
Yes, I don't know Apex enough to give my opinion on it. I do agree that choosing a framework, a good framework, is a wise thing.
So why don't I answer that a little bit? So the person who asked the question is right, is correct that Apex does a lot of the work for you that, let's say if you're using a Java layer on top of Oracle database, you have to do more of it yourself, or they have their own frameworks that they can try to leverage. But it's hard to match the application development productivity of Apex because of its tight connection to the database. In that case, probably using 100% PLSQL APIs driven by table functions instead of select statements against views, you can still do it, but it's not only a bit more of a challenge perhaps, but also probably not necessary or not something that an Apex developer is going to dive in and do. So the bottom line, in my experience in Apex, is that when you can use the default capabilities to generate pages around tables and use the default DML, do it. But for most of my user-facing pages in which I have to do a lot of tweaks to the API and the process flow, we end up writing our own DML statements, but hidden inside the PLSQL packages. Let's keep going. It looks like you define a lot of types needed for PLSQL parameters and return types. Do you find those in packages or at the schema level so they can be used in SQL?
Okay, so I actually said that unfortunately we define them in the schema level, not all of them. There are types that I would have defined in the schema level anyway. So we can use it anywhere. But there are types that are very specific, and the proper place for them would be in the package spec. But because we cannot select from them, and we really, really like this option of selecting from a collection, you can do it in 12.1, but in 11G you cannot. So this is why we define most of our types in the schema level.
And this is actually another question that came up. Could you please repeat one of the best features of 12c regarding UDTs, user-defined types? So why don't I just cover that real quick. So prior to 12.1, if you had a function, a table function, which means the function returned a collection, and you wanted to select from that table function, which is a fantastic feature that Oren's been mentioning several times, you had to use a schema-level type for a nested table or a V-array, not associative arrays. In 12.1, you can now leverage table function capabilities for associative arrays, nested tables, and V-arrays. So that's been opened up as part of a broader enhancement to allow you to access PLSQL user-defined types through the SQL layer. So that's generally speaking what's going on there. All right, let's see. My team resists the use of for loops. They find it confusing when returning only one row. Oren, would you like to take that?
In the cursor for loop?
Yes, I assume that's what that is. How do I change their minds?
So what do they do?
We don't have that answer. So Jace, I'll take this real quick. If the objection is, I don't want to use a cursive for loop to return just one row, you should say, you're right. Never use a cursive for loop to return one row. I've seen that happen. If you know,
right.
that's right.
If you know in advance that you will get maximum one row. Sorry.
Exactly. So if you're doing a single row fetch, I've seen people use a cursive for loop. I won't even tell you some of the strange and embarrassing places I've seen it. It's a matter of laziness. I don't want to declare the record. I can just write the cursive for loop. It does it all for me. But it's very misleading. A loop is implying more than one row, or it could have more than one row. So if that's the objection, they don't want to use a cursive for loop for a single row fetch, you should say, I agree, put the select statement inside a function, call the function. But for multiple row fetches, if you're going through every row in the set, cursive for loops are the best way to go performance-wise, productivity-wise, and resilience over time. And let's see, number of great presentations. Thank you, Oren.
Thank you. If I may add, Stephen,
go ahead.
If it is important to get exactly one record, then the select into is even better, right? So you know that you didn't get this one record, and you can catch it with the exception of no data found.
I should have been more clear about that, right?
The for loop, the for loop will succeed because it's okay to get zero records in a for loop.
Exactly. So a single row fetch should always be done with the select into inside a function. Thank you. I didn't make that explicit. So for enhanced performance of your Moovit database, have you found it important to design your SQL queries and PLSQL functions to use parallel execution?
We cannot use parallel execution because we use standard edition.
End of answer. And I suppose we could ask, why aren't you using extended edition, enterprise edition, but...
because it costs more.
That's why I shouldn't have asked. Can you elaborate a bit on how you do instrumentation?
Instrumentation? Basically, we have a core functionality of logging, and wherever we think it's appropriate, we write to the log based on a flag that either it is turned on or off. So we can turn the flag on, and then the instrumentation, the login is written to some central table of login, and of course it has columns of the timestamp and the procedure that call it and everything.
And I assume this is a procedure you're calling to do the insert into the table. And is there a pragma in that procedure by any chance?
We have two procedures. One is called write and the other one is write and commit. So it depends on what we really want. If we want it to be written even if the transaction will fail eventually, or to be part of the transaction.
Then you add the autonomous transaction pragma.
Right.
Yeah, just making sure that people are aware of that part. So when you're doing instrumentation, you're usually writing trace information. Even if your business transaction rolls back, you want to see the log of what happened. And so that insert procedure will have the autonomous transaction pragma, allowing it to commit just that insert without committing the outer transaction. Okay, and yeah, we're just about out of time. So here's, I think, the last question in my list. What are you thinking about, or what are you planning regarding 12c?
I guess we will get to the sometime. I don't know yet when will it happen. I just don't know.
And it sounds like you're doing fine on 11G release 2. There are some features in 12c you'd love to use, but you're making do somehow.
Right. That's right.
Sounds good. And now let's see, more on performance tuning. Do you hard code Oracle hints in your SQL statements?
In some places, yes.
Are there any particular hints that you found useful or ones that you avoid?
I like the cardinality hint, although it is not documented, especially when we work with collection variables. When we select from a collection variable, then adding the cardinality helps the optimizer knows that how big is this collection or how small it is. And this is kind of the hints that tell the optimizer that you give it more information rather than telling it how to do things.
Okay. And I think we'll finish up with this one question. It's an easy one. How do you handle performance tuning? And what's the common performance issue that you find in your application?
Okay, so I think the traditional ways is the answer. We use trace, we use explain plan. If we have a performance problem, then we trace it. We focus on the low-hanging fruit actually, and find the problematic queries and fix them. Like every. I think like everyone.
There's no magic.
No magic.
No magic. Darn. Okay. On that note, we have finished out our hour. I thank you very much, Oren, for sharing your experiences with us and your time. Thanks for everybody for attending, and hopefully you've gotten a lot out of this talk. And please do follow DB Oriented on Twitter. You can follow me too, SF on PLSQL. Check out his presentations that are available online as well, and hopefully you can start to leverage PLSQL and Oracle Database and EBR as they have done at Moovit.
Right.
Thanks so much.
Thank you very much, Stephen.
Welcome.
Great. Thank you, Oren, and thank you, Stephen, for today's presentation. Just as a reminder for our attendees, please complete a post-attendee survey so that we can gather your feedback for future sessions, and we'll post a copy of this recording for future playback. Thank you, everyone, for attending.
Take care, everybody, and happy PLSQL coding.